Now, today, inshallah, we'll speak about converting any while loop into a for loop in 3 simple steps. So I can convert any while loop into a for loop. Now, to start with, let's think together. What are the main structures of the while loop? What are the main parts? The while loop. I cannot have a while loop without a condition. While it has to have a condition between parentheses, right? The condition is a logical expression. If it's true, it will keep on executing whatever inside this block of code. So we have a block of code here. It will keep executing it while whatever in the parentheses here is true. Am I right? Great. So there is here an expression. So I just write exp, expression. There's nothing like this in programming. Just I'm writing down here. And there's here the program, the code or the statement, the program, the block of code. So I'm just writing English now, just to explain the concept, okay? Now, and then will it execute like this?
No.
It still needs some 2 things to be done. I have to have a counter or something that make this loop to exit. Maybe if it's sentinel loop, so I have to have like increment or decrement, so it's updating a variable, and I have to initialize a variable. Okay, so I have a variable, I have an expression here based on this variable maybe, and then a block of code, and then increment this variable. So to be practical, if this is int I, and then here I is less than 40, so I'm solving the first part of the homework. If I starts with a 0 and ends before 40, 39 means, and then every time the block of the code is nothing but cout the star, and then I have to increment what? The I, so I++. That's it. So I'm done writing the while loop. So I've solved half of the homework question. If I'm gonna execute this thing here, this is a for loop, I've got an error. I lost 1 semicolon missing there, so this is fixed. Fine, so I have these stars as an output, 40 stars. Great. Now, I would like to, after finishing things up, let's cout and L, just to make things look better. Yeah, this is much better. Now, going back here, I would like to transform this while into a for loop. Now, we have 3 main parts. This is the first part. I called it initialization part, and this is the condition part, and then this is the incrementation part, or updating, because it might decrement as well. Changing while into for loop, I undergo these 3 things. No, this is for, and I put a semicolon before the condition and semicolon after the condition. What the first part here, grab it and put it here, and this part here, I grab it and put it here. That's it. I no longer need the semicolon. Now this will work exactly as the while loop. Let me execute and see what happens. Did I have? Oh, from copying things, yeah. Fine. So see, it's exactly the same output. Exactly the same. So for loop, while loop are exactly the same. I can interchange between them using these simple steps. Having two semicolon here inside the parentheses will break it into 3 parts. Okay, if I have two semicolons inside a parenthesis, it will break them into three parts. The middle part remains as in the while loop, the condition. The first part, this part here is the initialization. You have to start from somewhere. And the last part is the update part. Either you increment or decrement. So initialization, condition, and incrementation. These are the three Asians, if you can say. Okay? Three Asians. Incrementation, initialization, condition, and incrementation. Fine. So one might ask a question, why do we need to have two ways to do the same thing? Is while enough? Do I need really to have a for loop to do the same thing and just have all this burden on me? Now, in the while loop, in our case, if the while is short enough, you can see everything in one snapshot, okay? Now, the initialization is there, the condition is there, and the incrementation is there. But actually, in real-time programming, you can never, most of the time, programs are long. And if the while loop is so long, it can spam to 3-4 pages. If I would like to understand what's going on, I have to go to the end of the while loop and see by how much it's incrementing. See, I have to look up there where was the I first initialized by what. So I have to look maybe far up. So it will not give me the clear understanding at a glance. But here, as a control panel, everything in front of me. I have I'm going to start from here, this is the stopping condition, and this is how much I'm going to add every time. Control panel, everything is in front of me, so it's much easier to see it. So this is where we would like to have for loop instead of a while loop. While loop, it's more natural language, more to our language. While it's still true, do so and so. But for loop, it's not the way we speak. But I can easily say, while I'm giving the lecture, please don't speak to each other. So while this condition is true, be silent. Fine? But it's really odd to say, I'm speaking, don't do anything. It's really odd. We don't do it. We don't say it. We don't speak it like this. But so the while loop is closer to how we speak, but the for loop is easier to how we see it. Okay, so each one has its plus and minus. Now, this will take us to the second part here of our lecture. So we're done with the for loop. Now, if I would like to repeat this 40 times to close my homework, what to do? Embed it inside another for loop, that's all. Embed it inside another for loop. So if I'm going to say like for int j equals 0, j less than 40, j plus plus, j plus plus. J is different from I. So, this is a typo, thank you. I'm going to open the brackets here. Open the bracket. So this is all inside this bracket, all the way with this and L. Yes, then I'm going to close the brackets here. After this thing here, I'm going to close the brackets. This bracket is for which for loop? The first for loop. So I'm going to write down a comment here for J. And I'm going to write a comment here. This is for I. So I just know which is for which. So this bracket is for this one here. And this bracket is for this one here. Fine? If I execute this one, yes, this is what I got. I got this 40 by 40. Okay, it should be a square, but since the screen has a single space or between line and line, there's some space there. So it will be as if it's a rectangle, but it's not a rectangle, it's a square. Fine. So this will take me to the end of the for loop, and I'm ready to go to the switch. Any questions? Any questions? Okay. Now, yes? Yes, yes. The question is, can I start I from 1 instead of 0? The answer is yes. But if I start from 1, it has to be less than or equal to 40. Otherwise, you're going to count 41. Because if I'm going to count from 0 to 9, these are 10 digits. If I'm going to count from 1 to 9, these are 9. It should be from 10. If I'm going to count from 1 to 10, these are 10. If I'm counting from 0 to 10, these are 11. So it should be less than 10. Switch. We are ready to speak about switch. Switch is like this. Switch. If I am to use the switch, it goes like this. This is the structure. And then I have case. Say, if I'm going to switch on the variable x, so case if x is 1, it's going to do something. If case is 2, it's going to do something else. And all the way till this is semicolon. And I have here int x, cnx. I'm going to enter x, and here I will write, for example, cout you pressed 1. And then here, cout you pressed 2. Fine. Let's execute and see what happens. It's int x equals 0. No, int x. I just took out these curly brackets, so it's complaining about that. Yes, allow it. It's asking for x. If I print 1, you pressed 1 and 2. If I press 2, it will print you press 2 only. Any suggestions? Did you conclude anything? If I pressed 1, it's printing you pressed 1 and 2. If I press 2, it's saying that I pressed 2 only. Okay, let me add case 3 here. Control C, Control V. So this is 3, and I have 3. Execute. See what happens. 2. What will you get? 2 and 3. If I press 1, 1, 2, 3. If I press 3, it's 3 only. So it's starting. The switch will start from wherever the case match, all the way down. Okay, all the way down. If you don't want it like this, then just give a break after each one. So after this, just give a break. After this one, give a break. After this one, I have a spell here. Yeah, give a break. Now let's see what happens. See what happens. After this one, I have, okay, number 1, one alone. Again, number 2, that's only 2 is pressed. See? Can you see back there? Okay, fine. So now, did you know what's the reason of having a break here? A break will stop, will just take the execution out of the switch. The switch will direct the execution to which of the case that match X, if case 1, case 2, case 3, and it will continue doing things. Like, for example, if I have another statement here, cout, thank you. So it will execute this one, execute this, the second one, keep it executing till it reach a break. Okay? So I have thank you with number 1. Thank you, but with 2, I don't have any thank you there. Number 2, it's normal. Okay, so this is all about switch. This is all about switch. So it saved me time. Can I use the same concept with some other control structure we've learned before? Exactly, if else. So using if else, I can do exactly the same thing without even bothering about switch. But what gain did I benefit from switch? It's not about repeating. Yeah, repeating the condition every time between this and that. Okay, fine. But it's clear. Yeah, it's clear. But there are some drawback here. But th- those are the benefit that you just said. But there are drawbacks. I cannot have a range. If I want, for example, if x is between 1 and 2, sorry, from 1 to 10, then I have to do like this. Okay, see. Case 2, case 3, case 4, and so all these well, thank you, you pressed 1 to 4. It will be clumsy. And case 5, case 6. See, now if I press 3, yeah, you press 1 to 4, thank you. If I click 5, you pressed 2. Okay, I didn't change this. It should be I pressed 5, I pressed 6. So see, for the if statement, the benefit is I can have ranges. See the guess the number problem that I gave you? Temperature, it was a temperature. Guess the temperature? No, guess the number. And hot, cold. Yeah. هاي لعبة البارد حار تعرفونها؟ Yeah. ف guess a number. I don't think you're gonna do it like this, because if you're gonna have if you're gonna have like from 0 to 100 the range of the guess, it's really hard to put 100 cases there. You have it's discrete متقطع, discrete, not continuous. Okay, you have a beautiful example. I would like to have case 1 to interact with, case 5 to interact with differently, case 6 to interact differently. Any other case, I should write something else. For example, I should write default. Default will grab any other unmatched case. So I should write here, for example, cout, you did not press 1, 5, or 6. Okay? Now let's see what happened. Now, case 2, you did not press 1, 5, or 6. If I press 5, I pressed 5. If I press, see what I mean? So default will grab any unmatching case. Okay? So this is what's called by default. The switch thing is really useful in menu. If I have a menu, I would like to select one of the menu, and then the default will grab, if the menu is 1 to 5, and you press, for example, 6, 7, 8, the default will grab that error entry and will say, you should enter from 1 to 5, for example, if that's a menu. In switch, I must put case and default. Yeah, these are important. In the switch, all you have, this is the structure of switch. The switch is like this. Switch, parentheses, you have something here, the variable, that upon which the value, it can be, for example, a character. If this is a character, I can put, for example, A. And this is car, C-H-A-R. And I'm going to enter character. If it's A, you pressed an A. Cout, you pressed an A. Yeah, it can be anything. Execute A, enter, you pressed an A. Okay, so it can be a character, it can be a number. I must put semicolon after the curly brackets. Which curly brackets? For the switch. Yeah, this is a must, because this will end the switch. The switch is ending here. This is the continuation of it. Okay, because consider the switch as a statement, and it only ended here.
Switch is the only statement which ends semicolon.
Yeah, and it ended only here, because all these توابع مالتها. Huh? Now let's have a for loop. If I write for int x equals 1 semicolon x less than 10 x plus plus, and then cout x semicolon. Now what will this print on the screen? It will print a number at a new line. Yes. Is it from 1 to 10? Is it? No, it's from 1 to 9. See? Why? Because we stated in the condition x equals 1 at the beginning, the initialization, and then it goes all the way to x less than 10. So it will go from x up to 9, 1 up to 9. Now, if I would like to have another statement, I should combine them into curly brackets. So now I am binding these two statements so that both will be executed 9 times from 1 to 9. If I write down here, if parentheses x equals 5, then break, what will this do? Remember the break that we have in the switch? It causes the execution to get out of the block. It will be the same if we do it here. So if I put if x equals 5, means if it's 5, then it will break the loop. Means it will go from 1 to 4, and once x equals 5, it is outside of the loop. Now, if I replace the break with a continue, it will skip that iteration. Iteration means a turn. So it has 1, 2, 3, 4, and then when the turn came to number 5, it skipped that one, that iteration, that turn, and started a new turn, a new iteration, which is at number 6, and then 7, 8, and 9. Okay, now we are ready to discuss a total new topic. If, for example, I would like to enter a number, so I would say, for example, after opening a new project, as I have here, I just float, this is a floating point number, and then cin, I'm gonna read that number and just simply cout, print it on the screen with and L to have a new line after printing that number. So this is what I'm gonna do here. So if I print, so if I have here an integer, for example, say 3, it will print it as 3. If since this is a floating point, so it will accept 3.5 as well, or 3.45, let's say. So it will print 3.45. If I'm gonna compile again and have it say 4.5, so it's 4.5. What if I give it more precisions, like 2.34567 8 9? Let's see what happens. So it cannot deal with more than 1 2 3 4 5 precisions, since this is a floating point. So this is its limit of the accuracy that it can hold. So we can say, for example, this is something new here. Before I print x, fixed, and now compile it. Now 2.34567889. Now we got the full precision. Since this is a fixed notation, it will give me the full range that I can go with. And we can see here that it has rounded the last digit since it couldn't hold it. So 8 was converted into 9. And if I compile again and give it a smaller number, say 2.3, it will fill the rest with zeros. The same can be said with float. So if I float and 2.3, the same thing can be said here. Now, say for example, I would like to print x, and then this will be printed normally without the fix. Then I want to set w 5 and then print in a fixed notation x again. So this is what's denoted here. So I'm gonna print x normally, and then set w 5 means I'm gonna give a width of 5 spaces, included whatever gonna be printed after that. This is in the IO manip library, so I have to include that library. Include IO manip, otherwise it will give me an error. So if I'm gonna compile, now I'm back here. If I say 3.5, now I have 3.5, then 3.5 in the fixed format. I think I didn't give much space, so just I'm gonna include 5, make it to 15, and just repeat the same output here. It's 3.5, 2.5, sorry. So it gave me 15 spaces between them. This will look better and easier to read. Now this is to end up our experiment using the float, double, set w, fixed. Now we would like to see some experiment with fixed precision. So for example, if replacing fixed is always giving me this 5-digit precision, well, instead I would like to have my own precision. So I would say, for example, set precision, and say for example 3. So it will fix it to 3 precision. This is the accuracy of my number. So if I'm gonna say 3.456, see now 3 precision will give me 3.46. 5 has been rounded to 6 since the following number is 6, so it's closer to a full number. So this is why we have 5 into 6. Precision 3 means I have, this is 1, this is 2, and this is 3. So I have 3 digits. If I fix it to 3 means it's fixed to 3 digits only. What if I have more than 3 digits, say 1003.4? Then here I got this engineering notation. If I exceed the 3 precision, then it will convert it into an engineering notation, as we have seen.
Now say if I would like to set the precision, so if I say for example only one digit, if I execute this code here, I get say 3.4, then it only keeps one digit. If I have, say for example 100, then it is converted into an engineering format, because it will only allow me to have only one digit. If I say for example make it 5 digits, now if I execute this thing and I have like 100.234, then it counts 1, 2, 3, 4, 5 digits, and it just actually round the last digit here. So 4 will be truncated since it's less than 5. This will finalize our experiment here using the set W, fixed, set precision, and floating point. If we would like to have using this knowledge to calculate, for example, the average of the student in the class, so say for example I will have here a for loop for int I equals 0, I less than, we have 10, I plus plus. Every time I will add cn, get something from the user. This is grade, then the sum plus equal grade, and that's it. We have to define here int grade and sum. We should initialize this to 0, but grade, since I'm gonna enter the first number before using it, so there's no problem if I don't initialize that one. Now here the average should be a floating point, so float av, and av is nothing but av. Okay, let's put some here. Av is nothing but the sum divided by 10. Then cout av Now, if I leave this, then this is an integer division. This will create a problem because sum is an integer and 10 is an integer. So to solve this one, I have to put either 0.0 or cast the sum into a floating point number. Now, doing that, I can have 10 numbers, and the average is 5.5. Adding all the numbers from 1 to 10 will give me 5.5 as an average, because if I add them is 55 divided by 10 is 5.5. So this will fix it here. Now, as you all know, to convert this into a while loop, I just take this counter outside the while as an initial value, and take this incrementation of the I inside the while at the end, and this just remove the semicolons to finish things up. I just put one here. Now this is how I convert a for loop into a while loop. Now if I repeat the same thing, I get the same value. Now to do this is if I know number of students. Now say I don't know number of students, but all I know is that once I'm done, I would like to enter a negative value, say -1. So I will say here, so instead of having this I counter, I no longer need it. Maybe I will need it to count number of students. So I just I will int I equals 0. Okay, fine, I leave it there. But instead of having the I as a controlling value, I will check the grade and see if it's still greater than 0. I'll keep adding grades. Now at the beginning I don't have a value for grade. Now this is a problem because grade is not initialized. So I have to give it a value. So it will start by having it 0. So now this should be greater than or equals 0, since student might get 0 grade, and every time I'm entering a grade, adding it to the sum, and then incrementing I will hold number of students. So at the end this should be divided by I, and I'm left with this casting problem. So maybe I'll have a casting float for the sum, and I still have another problem. I have to decrement I by 1, because at the end, if I enter -1 as a grade, I should not consider this as a student. So I shouldn't add +1 as to consider -1 is a grade of one of the students. So this is why I decrement I here by 1 after I increment it inside the loop, because there's no way I could known about that only after I've checked that the grade is less than 0. So I exit the loop and then decrement I, so I get the correct number of students. This is where I will divide the sum by number of the correct student, and then just print out the average. I'll have a new line here. Say for example, if I put 5, 5 and 5, then -1, we get a wrong result. Instead of having 5 as the average, we got 4.6667, and that is because the sum here is adding the grades, and it added the -1 that has been entered as a sentinel to exit from the loop. This -1 shouldn't be added with the sum, and hence the sum was 14 instead of 15, and this is why we got 4.6 instead of 5. Now to fix this thing here is we should say something like if grade is like greater than 0, then do the add it to the sum. Otherwise, if it's less than 0, then don't add it to the sum. If I executing this again, now 5, 5 and 5, then -1, I get the correct answer. Now if I execute again and have like 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, then -1, I get 5.5 as an answer, and this will conclude my code here, having any number and then to terminate -1. This will give me the average of the above 3 numbers or 4 numbers, depends on how many numbers I enter. Once I've done, I just enter a -1, so -1 will be entered as a grade. I should not add that grade to the sum. I only add if it's greater than 0. Then I is added, it's incremented by 1. This is where I fix it after the loop. I just decrease I by 1, and then the average is the division, the floating point division. So I'm casting it here. There's another way to cast it, static cast, then I do something like this, float. So this will this is exactly the same as just putting a float between parentheses, and then Yeah, I need to put parentheses. So static cast the float, then parentheses sum. This will have the same effect of having the float between parentheses. Actually, I prefer the first way, but this is also written in the book, so we explain it here just for the sake of it is in the book. Now 1, 2, 3 and -1, the average is 2. If I execute again and have like 5, 4, 5 and then -1, it's 4.6. And so this is using the while loop. Now there is another way. Instead of while, we can use a do while loop. So do while is exactly same as while, but I take this, put it at the end of the block, and it should be there should be a semicolon after it. Then I just write here do instead of having the curly brackets alone. Now this will execute. If I say 1, 2, 3 and 4, I have this 2.5, so it's giving me the same result. So do while loop has the same effect of a while loop, except that the while can have a case that it won't execute if the condition is false, but the do while loop will execute at least once even if the condition is initially false. So just imagine if that condition is initially false, the loop will not enter if in the case of a while loop, but in the case of a do while loop, so it has to go through the whole block before it checks the condition. And here we have this is the difference between a while loop and a do while loop. We can show that in a simple example here. For example, if I have an integer I and ask the user to enter I, and then if I have a while loop, there's a counter starting from 0, and then while the counter is less than I, less than or equal to I, then I'm gonna keep printing I. Sorry, I'll keep printing counter. So this should go to cout, keep printing counter, and then every time just plus plus. So I keep adding the counter after I print its value. It will keep adding counter till it reaches I. Now executing this code, if I have say 5, so it will count from 0, 1, 2, 3, 4, 5. Let me have an andel to have them. Yeah, so now if I 10, then I have from 0 to 10. If initially I execute this code and initially I have say 0, then it executed only once. If I execute and have say for example -1, then it did not execute. So if I have a negative value, then this is initially false, because I starting from 0 and -1. If I is -1, for example, counter is starting from 0, so counter is not less than or equal to -1 or any negative value. So this is why any negative value, say -5, will not execute, and actually it will not enter this code here. Now if I if I change this while loop into a do while loop, as we've seen, this is step 1, step 2 put a semicolon, step 3 just write a do here, then execute. Now putting 10, it has the same effect of the while loop, so this is do while, have this exactly the same effect. If I put, for example, 5, it's the same, but when the condition is initially false, such as -5, then this is the difference. Now it 0 means it has been executed at least once, means even if this condition is initially false, it went through this code here and it printed the counter. Initially it was 0, it added 1 to that counter after it has been printed, and then it found out that the condition is false and it's executed. It's just exit from the loop. So this means the do while loop will execute the body of the loop at least once, means even if the condition is initially false, it will execute it once. But the while loop, it will execute if the condition is true, and if the condition is false, it will never enter to the body of the loop. So this is the main difference between the do while loop and the while loop. By this we reach the end of topics covering chapter 2, and we are ready to go to chapter 3. See you in next video.